Okay, let's wait a minute for everyone to join. Can see a few more people joining. All right, so let's get started. Hello, everyone, and welcome to this podcast by SlashData, or this webinar by SlashData. My name is Andreas Constantinou. I'm founder and CEO of SlashData, joining you from Athens, Greece, where it's, I think it's around 28 Celsius or about 80 Fahrenheit for our American friends. Let me open, firstly, starting with a confession. So 5 years ago, I stepped away from the CEO role at SlashData because I had run out of passion, to be honest, for software and developers. And after nearly 2 decades in that job, the space felt kind of predictable and tired to me. And then, of course, everything changed. AI arrived and it made everything unpredictable. So I came back, among other reasons, for the passion of understanding how AI is changing software development, because it's radically changing it. No one knows how software development will look like in 3 years, but we have a pretty good looking glass by the virtue of the data we're collecting, and that's what we're trying to figure out, and the question we're trying to answer. And that's also the question we're trying to answer today with data instead of opinions. For those of us who don't know SlashData, we've been in the space of researching software development and developers since 2005. Yes, that sounds very long time ago. We survey tens of thousands of developers around the world every year, and companies like Microsoft, Google, and Meta use our research to understand how developers actually work, what tools they're using, and how to engage them. You can think of us like the analyst firm that sees the future of software development before anyone else. Thank you also to the partners at On Marketing, Panos, Apostolis, Stelios, Vitali, for helping us out with this webinar. Now, what you get to hear in the next 45 minutes or so, fresh data on how developers use AI coding tools, and not all the usual talk about let's go 100% AI generated code, because that's not where the trust issues are. The gap today is between tool adoption and trust. Many companies are moving to 100% AI code generation, but developers are not going away, and value is moving to where the trust gap is. And it's low in several fronts, as we're going to talk about. I want to encourage everyone to ask questions during the presentation, and I'll surface them so we can keep this interactive, but also nicely flowing. And we'll have dedicated time at Q&A at the end. And also you'll get a link to download the full report at the end of the webinar. Now, a quick word on who's in the room today. We have registrations from quite a lot of different companies: Microsoft, Google, Amazon, NVIDIA, Intel, Qualcomm, ARM, Broadcom, and PayPal, alongside founders and product people from AI native tooling companies. So the people building the chips, the platforms, and the tools developers use every day. Now, I would like to not delay this any further and introduce Liam, who's the person you actually came to listen to. Liam Bollmann-Dodd is our principal market research consultant, joining all the way from Vienna, Austria. Liam has a PhD in physics and spent his earlier career at CERN doing antimatter research. So as you can imagine, analyzing developer survey data is, by his standards, the easier job. Earlier in this year, he presented the State of Cloud Native report that we co-authored together with CNCF at KubeCon in Amsterdam. We'll also be there later this year. And Liam leads our Developer Nation research, waves spanning over tens of thousands of developers. Liam, we're very keen to hear what you have to say.
Thank you. Thank you. So as Andrea said, any questions at any time are more than welcome. So what we're going to look through today is basically a very high-level overview, but very kind of impactful overview of how developers are using AI to help them with development tasks, but then more importantly, how reliant and how dependent they are on AI for these tasks. And I think that also gives a good understanding of where the market sits right now, where AI has capabilities, when developer trust really has to be earned at a much, much higher level than one might expect for other areas. So basically, we're going to break down two options, and the first one we look at is an overview of like where developers are adopting AI. So the first thing that many people may notice is they may see that the number for code generation, while the highest, is at 49%. About half of developers are using AI for code generation. An important context to remember with SlashData's research is we don't focus just on programmers, not just those who are writing code, those applications. A developer to us, anyone who is involved in a technical capacity with the software development lifecycle. So as you can imagine, maybe someone who is a DevOps professional or an SRE person, they may not do a lot of code generation as part of their tasks, or when they do, they may do small scale, and they may want to be involved themselves. Other people may do more, code reviewing. That may be the position they are in now, so therefore they don't do the much code generation. So to put that into context, when we look at like the tasks that people are using AI for, it's important to kind of take that kind of understanding and context with it. And generally, from presenting this kind of overview, we don't find that this result in itself too unexpected. So we ask developers who are using AI assistants what they're using AI assistants for. Code generation leads, editing, modifying existing code second, and then bug detection, understanding existing code, and generating documentation kind of follow as the leading five. And then I guess the least popular, we have identifying security issues, performance profiling, handling DevOps tasks, and then managing pull requests or merges. So with this data, we kind of get two different kind of measures emerging at the same time, which is the first one is like there are popular tasks that are going to be popular, and therefore there's more developers who may be using AI to assist with those tasks. Like code generation, very common task. Editing, modifying code, bug detection, understanding existing code. These are very common tasks, and therefore we would expect to see them, if AI is capable, to be popular tasks that people are doing with AI. When we get to the lower tasks, there's a combination of activities happening. There is the difference of tasks that maybe AI is less well suited for, so AI is not being used for it because people don't think AI is a good fit for this, and then tasks themselves are less popular. And I think the kind of good clarity and comparison is handling DevOps versus managing pull requests. Many developers today don't really handle DevOps tasks, or if they do, it's done for a platform such that they're not really yet focused on it. Therefore, they may not even consider AI as like worthwhile because they have the kind of GUI interface, or they have the emails from the DevOps team telling them what to do. On the other hand, managing pull requests and merges is something that pretty much anyone putting code together is handling at some point in their job. So the fact that this is such a low option for people with using AI to assist them suggests that like maybe people don't think that AI is actually that good a fit for the task. But from that we can get just a reverse side there. But from that we can get a kind of more interesting and more kind of impactful understanding of what the AI ability with development assistance looks like. So what this chart shows is on the x-axis or the horizontal axis is how many developers who are using AI assistants, what proportion of them are using AI for this task. It's just the previous chart rotated to be on an axis. While the y-axis or the vertical axis is what we call the reliance factor. So we take the people who are using AI to do the majority of this task and subtract the proportion of people who are using AI to do the minority of this task. And majority is 50%. And then from that subtraction, you basically see like a kind of an AI reliance, like positive or negative. So the higher the number, the more developers are using AI for the majority of the task. And the lower the number, the fewer developers who are using AI for the majority of the task. Basically, one way you can view it is that the higher the number on the vertical axis, the more the developers trust in the capability of AI to handle this task. And also another important bit of context with this is we say majority. We're not even saying 90% or 100%, as many people claim. That like when you hear like words like AI is a solved, like coding is a solved problem, the data does not reflect this in any reality. The data does not say this is the case at all. What we instead see is that we see kind of a peak and normalization between 25% and 75%. So there's much more focus in the middle than there is on people who are saying that coding, like AI is handling 100% of their coding activities. So with this, we end up with 4 quadrants, and the quadrants are defined obviously. The vertical axis, 0 is a hard line. It crosses whether it's majority AI or minority AI. And the x-axis, we kind of drew what we call arbitrary, but I think it's a fair arbitrary line, which is that if a task is done, AI is used by more than a third of developers for a task, then we consider that to be like a kind of a high adoption rate. And if it's less than a third, we say it's kind of low adoption. And that gives us basically 4 kind of quadrants to understand, which is the proven and unproven. So high adoption, high reliance, low adoption, low reliance. And then the hyped ones were underhyped, low adoption, high reliance, and overhyped, high adoption, but low reliance. I'm going to go through each of them because 3 of them are kind of show a good cluster of behavior and understanding of what AI tools are. And the 4th one is more complex and maybe has some areas where people can kind of find kind of product niches and product gaps. So if we focus on the proven sector first. So proven is developers may trust it, but who want to trust AI to this task. And unsurprisingly, what you see here is generating documentation, generating code comments, and generating tests on mock data. Anyone who's been a developer for a long time knows the importance of code comments and knows the importance of good documentation. So how do you measure reliance on an AI for a task? That's actually important to ask. So we use survey data that's how all of our data for DN is collected, is survey data. We asked developers, do you use AI for tasks? Or do you use AI in your development? Those who said they did, we then asked them what tasks they were using. All those tasks, we asked them what proportion of this task was handled by AI. So obviously there is of a human perception of the task, but even when you consider maybe humans would overestimate or underestimate, you have to consider that developers are often being tracked in their kind of hours. And even if they say like, when you think about them, the task is often the hours component. So, maybe the AI code generation generates 1,000 lines in a few minutes, but that still takes hours of a developer to go through and make changes and fix things and carry on. So they may say they're still doing the majority of the task. So it's up to interpretation based on survey results.
Liam, can you remind us how many people this was fielded to? How many developers this was fielded to?
So the survey was fielded to more than 11,500 developers, and the data for this report comes from 4,659 developers who indicated they were using AI for various tasks and provided data on it. So going back to the quadrant, we have the proven sector, which is the high adoption, high reliance. So developers are choosing to use AI for these tasks, and they're also allowing the AI to do the majority of the tasks. And unsurprisingly, documentation, code comments, and tests are the ones that pop up here. Anyone who's been a developer for a long time knows that there's a great importance to good code commentation, having readable code, and having documentation that supports what you're doing. But for most people, it's not the thing they love about development. It's not the problem solving. It's the kind of admin and cleanup to make sure everything is good. So many people are very happy to hand it over to an AI if it can do a good enough job. There are obviously concerns that emerge when you get the concept of if all documentation, all codes are generated by AI, you can get propagation of errors where the code has an error in it from one AI. When it's ingested by another AI, it's going to help with the next stage. You can kind of get cascading issues, so something developers should be aware of when it comes to documentation and code comments. And the second one is generating tests on mock data. And this one, obviously, for many people, this is one of the really, really beneficial uses they've found with AI development tools. Generating tests is a kind of very fiddly and kind of, for many people who don't like it, kind of a lot of effort you're putting into a task where ideally it never has to be seen. That's the kind of worst kind of task that happens, a task where if it works smoothly, these are never shown to light. So people are obviously happy to hand over this task to AI. There are obviously concerns when it comes to handing over the full responsibility. One must be sure that the tests are accurate, the tests are true, the tests are being tested correctly. People always like to find examples of where AI has written a test and there's an issue with the test when you ask the AI to fix it, it just deletes the test rather than actually fixing it on a technical level. So obviously there are concerns that should exist around this, but we can see that when developers like kind of understanding of how they want the AI tools to work and the kind of current level of technology, these tasks very comfortably fit within the kind of proven quadrant. The next quadrant is the kind of the overhyped quadrant. I think we've lost
Liam, sorry, there's a question. I know you repeated it earlier, but I think it's someone who joined maybe later. How do you define reliance?
I answered that question with the survey data. The proportion of those who use the majority AI for the majority of the task minus the proportion who use AI for the minority of the task. It's also the footnote at the bottom. And that's taken from survey data where the developers are asked about how much AI handles that task for them. So when we get to the overhyped section, unfortunately, this dot here on the end, that is code generation, just as a note. But in the overhyped section, we see there's a high adoption. So a lot of developers are using AI for these tasks, but the majority of developers are not allowing AI to handle most of the tasks. So we have code generation, which is on the right, bug detection, understanding existing code, and the one sitting at the lowest in reliance is editing and modifying existing code. So there's lots of news and lots of media, lots of hype on the ability for coding tools to kind of handle code generation for developers. And while I think that we all know, and anyone who's used it has the ability to do so, there are many issues developers find with how these coding tools do generate code. Like, there's a reason why like people got really excited about the caveman skill, because like it turns code from being both smaller, even though it still consumes a lot of tokens to do so. So you win some, lose some. But developers are clearly, in our data set at least, are not fully handing over the responsibility to AI. Or as I could have said earlier, it could be AI does a lot of code generation in terms of lines, but in terms of effort or in terms of time, developers are still putting a lot of time working on code generation. Similarly, bug detection exists here, understanding existing code as well. Understanding existing code, like many people may say, is a context problem that as the context window gets larger, developers' reliance on AI may increase because they're comfortable that the AI has a full understanding of like kind of the full code base. Like, and that may be the case, and that may be true. But has anyone who's worked on code base, there's often things that are kind of, I don't want to say magic is the wrong word, but they're kind of like there's insights you get and ideas you get from working with code that may be better understood by someone who reads it and understands it doing it yourself rather than fully relying on AI to communicate this for you. But the biggest area we see, kind of the lowest reliance, is editing and modifying existing code. And the reason we think for this is because we find that similarly with serial refactoring, editing and modifying existing code is very limited in what you can do in terms of changes can have very large cascading effects. So if you generate new code, the impact of it not being good is you have to fix it, or you have to work again, or you have to do bug detection and bug fixing. Editing and modifying existing code often is going to impact the wider services. And the deeper you go into it, the deeper you go into tech stack, the more kind of the larger the impacts you can have. Add on to this that not only is can AI, like I said, be verbose, so a whole bunch of code that's not necessarily needed. It can have maybe not the high level of understanding of like how this impacts at a different level or a different user level. It also has the ability of not necessarily being predictable. So one of the nature of how AI tools, most of the coding tools work, is they're stochastic, they're not predictable. If you put in the same input, you don't get the same output. Which means that in terms of the code, how the people will get access and to use the tools, which means that the concerns developers have about asking to fix something and maybe in different ask or a different person were doing it, there's a slight difference you would get as an output, which makes it less reliable and less trustworthy as an approach to using AI to kind of go deep into the system, modify existing code. On top of that, because once you edit this code, you then have to do all the kind of tests yourself, all the fixes yourself, and make sure everything is working as intended. So AI in its current situation, developers are not trusting it as a place for editing or modifying existing code. So the most interesting one, I think, for many of the people in attendance, because it may see kind of seem to show some sort of kind of market gap, is the kind of underhyped section. So the underhyped section, there's low adoption, but among those who are using it, we're seeing that a majority, even if it's a small majority, are choosing to rely on AI for this task. And I think there's also there's kind of interesting differences that we see happen here. I think the two clusters we see kind of tell two very different stories. So on the right, we have the identifying security issues and performance profiling and optimization. So these are two tasks that while many developers will talk about security, many developers will talk about performance, as like a sole focused task that one works on, they're not necessarily the task that all developers will spend lots and lots of time on, which kind of like gets pushed down to like a low adoption rate. But also, like these are things that are still relatively common. Like most developers would have benefits if they were told that the AI can like do performance profiling optimization, if it can identify security issues and vulnerabilities. But among those who do use them, we do see like a slight lean toward relying on AI for it. And I think it's kind of a good, clear story. So if you're not a security expert and not a security like practitioner, keeping track of like CVEs, keeping track of the latest kind of best practices, the best hygiene approaches, how to keep your SDLC clean, how to prevent any vulnerabilities or exposures, how to prevent leaks, how to prevent secrets, cryptography. All these sorts of things are very complex if it's not your job to do it. And having AI that can basically do like a sweep of this, or do a check of this, or do a comparison against kind of the existing like kind of error and security detection tools makes this like probably quite a good opportunity for many people who security is not their sole responsibility. It's a different conversation. We're talking about CISOs and security experts who are fully relying on AI, but for the average developer, it's probably better than the kind of tools they were using already or relying on them to just handle it themselves. Similarly, performance profiling and optimization. For many developers, we've got very kind of lazy and greedy. We have compute, we have memory, we have data. We have the space to do things. We don't have to be as performance optimizing as we used to have to be. And also, it's not a task that's taught in the same way. Like the joke is anyone who uses Python, like to actually be efficient, you should be using C that's underneath it. So, like many people are comfortable with languages themselves are not the most performative, but an AI that can possibly find loops, possibly gaps where you can make things better, find kind of openings where you're doing this, there's no reason to do this, you should do this instead. Again, I think what we're seeing here is that maybe not everyone is using it, but those who are seeing the advantage because it's offering something they didn't have beforehand. They were not experts in these fields, they were not experts in these spaces, and now they have the ability to get a good leverage out of it. We're obviously not seeing a huge jump to it, but we're seeing like a lean that way, which I think is a kind of positive sign of where this can kind of hammer out like kind of niche but like very effective capabilities for many developers. But the managing progress and merges, I think, is the most interesting one because, as I mentioned before, it's the thing that most developers are doing, but it's got very low adoption for AI. But those who are using it, the majority are actually using it for the majority of their tasks. I think for many developers, handing over pull requests and merges to an AI is kind of one of these kind of final frontiers of being quite scary. It's very like this is the kind of core truth of record of your company and your code bases. Handing it over to an AI feels like something you don't really want to do. Many people who will remember like horrific merges or horrific push requests done when they like first join a company, and maybe they see the same like fear is built into them about it. But they're doing it, they should be okay handing over the task mostly to AI, which to me says that maybe this is an area where developers would be more comfortable if they understood it better, or if the tools like were shown to not make the errors they make. And I think this is one of the kind of things when it comes up to like many of the kind of these less lower adopted tasks, especially the lower adoption, lower reliance, is you're not just dealing with having the tool be able to be good, having the tool be able to be good in a way that and not be bad in a way that the existing things are. Maybe managing push and pull requests and merges is a pain in the backside for many people, but like it's never going to be a complete disaster once you've got everything set up in the way you have. But when it comes to maybe terrified, what your entry, maybe it will clear a database, maybe you're understanding why, or it will purge things, or
Liam,
like change your ownership. All sorts of scary things people have.
Sorry, your audio has intermittent clicks, and the last I think 10 seconds got lost completely. Can you repeat?
Yeah, I'll go back a bit. So basically, what I was saying was that for all the horror stories that people have about AI when it wipes the database or just removes some code or messes with production, all those kind of fear stories are existing when people think about how it could mess up their pull requests and their modes. And those who are using it maybe find it doesn't do this. Maybe the task is quite simple. Git is very simple these days. It's not a bad problem. We can handle it well. But you're existing in the media narrative and the positionality that when AI goes wrong, it wipes out an entire system. So maybe this is an area where developers would be more comfortable if they understood that it worked effectively and developers were interested in using it for this. And the last sector, I think, is where we have a bunch of different factors hitting at once. These are unproven. So these are low adoption and low reliance. So these are less popular for AI to be involved with, and then when they're involved, developers are not handing over the majority of the task to it. So much like before, it talks about with managing pull requests or mergers. I think handling DevOps tasks is very similar. People have fear about what an AI can do if it goes off the rail, and impacting DevOps sounds like a disaster area. So while a less popular task overall, I think people are also very fearful of how AI would handle it, especially when most people don't want to think about DevOps. They want to push DevOps away from them. They want to put it behind a platform or behind a team that handles that for them. But then integrating APIs and refactoring existing code, I think, are very separate, and where the issue is and how developer understanding of these are. So first, I think integrating APIs for many developers, the reason why they're probably low on AI use for this is because they want to make sure it interacts and behaves in their system as they want it to, and not just that how it behaves when they set it up, but they have an understanding of how it could behave or how it can behave or how it can interact with different aspects. You're basically pulling in in most cases a third party or case or something external. You want to make sure you not only have set it up correctly, but you understand where the kind of edges of it are and where the kind of factors that can impact the rest of your services are. So while developers want to have that hands-on understanding, integrating APIs may never actually raise to a task that developers are mostly rely on AI for. And instead, maybe become a task where they use it for fixing boilerplate code or setting things up or kind of just commenting things out when they're doing the integrating of APIs. But refactoring existing code, I think, gets back to what we talked about beforehand, where refactoring existing code is something that we're seeing more and more people talk about as a benefit of AI, that we can take our old code bases written in languages that are less popular or maybe less efficient or have less features than languages, and we can refactor the entire code base. And because AI will handle it, we can convert millions of lines into modern existing code. As someone who's worked on migrations, as Andreas mentioned, I worked at CERN earlier in my career where we were still using floppy disks and for a lot of our COBOL Fortran for a lot of our coding. There's a great fear about impacting systems that are written in old languages and have worked for a very long time. So that may inherently lean to a less reliance on it. But I mean, the second one is the impact that small changes can have the deeper they are in systems. That can lead to cascading kind of impacts that are hard to predict and hard to control. It's really an area where modernization and refactoring is something that has to earn a lot of credibility before developers are kind of happy to lean on it. You may see lots of management are happy to lean on it, loads of senior people who are happy to say, oh, we can refactor our entire code base. We're using AI tools, but that's the noise of people who are trying to impress people, trying to say that we're modern, and not people who actually deal with that task as a day-to-day life. And the more chances for error, the more chances for chaos, and the more chances for the error to something predictable that you then have to trace back through millions of lines of code possibly to understand what's gone wrong. Too many is not kind of showing as a place where they want to lean to. So that concludes all 4 sections of the thing, and I'll leave the kind of report highlights. Sorry, Jared Khan. I don't know, is the sound still bad? It says now. Has the sound been bad for you, Andres?
Yeah, the sound's been bad all over, and it wasn't that bad initially, but it's gone worse.
My suspicion may be my connection, so I will.
Yeah, but it wasn't. We didn't pick it up. We didn't pick it up initially, but only when we went live, unfortunately. Liam, I have another question while we have more from the audience. So developers are not going away. Where does the value of developers shift to? Where is AI not trusted yet? What's the kind of 10,000-foot view?
So if we go back to the kind of overview chart when it gets there. So for me, what I think the kind of area where developers are trusted, what developers value is when it comes to actually what we call the problem solving and the kind of actually building systems that behave and communicate to one another. When it comes to when you look at what people are handing over to AI, it's boilerplate, it's descriptive, it's administrative. Like there's the stuff that they don't want to do. When it comes to the things that are like actually challenging, where there's actual risks and where there's like a requirement not just of understanding code bases but practices, how people interact with it, how humans interact with it, how different teams and different servers interact with it. Like these things may be said, oh, this is just a context window of where AI can get better and get bigger. But I think that the value is that like, humans architecting and understanding the systems so that they actually function in a kind of in a work environment. Like for many people, there's this expression where you'll see the people talk about how they did an undergraduate degree in CS and they have done some certificates from some hyperscaler. They're kind of struggling to see like why people don't think they have the capabilities to do a job. But then when you take someone into actually work at a large company and see the expectations and requirements of a developer in the field, they don't match up to what is like a degree teaches. The degree teaches you how to do computer science or how to code or how to program or how to like architect. It doesn't teach you how to work with other people, work in systems, deliver product or projects, to manage things, to kind of control scope, control feature creep. Like there's the tasks that exist beyond solely the expectations of like pure code are where like developer like, will continue in my mind like have a value and a lot of importance.
Thank you. Can you go back to the slide with a link for anyone that wants access to the report?
Yep. I'll go there.
There you go. So let's see, do we have any other questions? So we'll be posting the replay, hopefully without the clicks. I don't know if this is an upload issue or if this is a has to do with source with Liam setup. But we'll be uploading the replay. The report you can find on our research base. It's a free download. And if you have an account manager at SlashData, you can also reach out and find out more information. Before we go, one more question. DevOps sits at the very bottom on adoption. Is that a capability problem or AI simply competing against automation pipelines people already trust?
So in my mind, I think it's both, but I think it's really that DevOps, especially over the last 10 years, has done a very good job at building, orchestrating, automating systems that make lives for developers easier in principle, but also make it so that there is greater observability, greater understanding, and kind of greater like kind of security and feeling of comfort around all these systems. Handing it to an AI, especially when the AI that like we think of when it comes to like generative AI, is basically having to compete with like things that are very well established and very predictable and very understandable. So your service, not your AI, not only has to be like good, it has to beat what people are very comfortable using now. Like I think we might see, in my mind, we might see DevOps as the future goes forward. We might see kind of drift back towards people using some other term to talk about more machine learning, more like kind of predictable AI compared to like AI now, which is more of a catch-all that includes like everything from like LLMs to world models to like protein folding models. Like AI now has lost a lot of meaning. So I think my view is in the future we'll see a lot more clarity around what AI is referring to in different cases, and if people have more trust in certain kinds of AI approaches to DevOps tasks, they might see them return and be able to compete.
And also to add, we're always looking for what are the questions we should be answering next. We run surveys all the time, several a month, and our waves run every 6 months. So we're always looking at what questions we should be asking developers so we can, as I was saying in the beginning, see the future before anyone else. It's a very fast changing landscape. So I think if we ask the right questions, we'll see where this whole thing goes. So at this stage, I'd like to apologize for the sound clicking. We need to improve on sound quality on the next one. And thank Liam for all of his insights and for preparing that QR code at the very last minute. Thank you, Liam. And thank you to On Marketing again. Thank you to everyone who's been watching. The report is there. If you want to access it, talk to your account manager if you have one at SlashData. And let us know what topics we should be diving on next. Actually, you can email me directly, andreas@slashdata.co. And take care, keep exploring, and let's explore the future of software development together. Bye, everyone.
Bye.